So today 7.3 is a very straightforward section. It's just all about solving trig equations. So knowing your background on trig from chapter 6 and from chapter 7.1 and 7.2 can be helpful. In general, they give us this outcome of theta, what you're allowed to get for your answers. So what we have to think of, or I guess I should say, the domain, what you're allowed to plug in for your thetas when we're solving these problems is normally in general between 0 and 2 pi, not including 2 pi. So you just don't have, infinite amount of answers. So first thing we're going to do is this problem says 2 sine theta plus the square root or the square root of 3 equals 0. So we're going to solve. In general, you try to isolate the sine or the cosine or the secant or the cosecant, just like when you're trying to solve for x. So we're going to say 2 sine theta equals negative square root of 3. Then we're going to divide both sides by 2. And we get sine of theta equals negative square root of 3 over 2. So now you have to ask yourself what theta on the unit circle, what theta would give you negative square root 3 over 2 when you take the sine of it? Well, we know that here at pi 6 degrees or 60, pi thirds degrees or 60 degrees, we would get that. But then that means that, but this is negative. So that means we have to find the equivalent in this quadrant and also in this quadrant. So if this is pi thirds, this is 2 pi thirds, this is 3 pi thirds, so this is 4 pi thirds, and this is 5 pi thirds. So then our theta is 4 pi thirds, comma 5 pi thirds. So these are the two values that when we plug them in, they will give us 2 times the sine of 4 pi thirds plus square root of 3 would give us 0. So by drawing the unit circle, it kind of gives you a heads up on what quadrant you should be in and what values you should be using. Okay, so let's take a look at this next one. This next one looks sweet and innocent, but it'll actually have a little bit of trouble with it. So the thing is it says that sine of 2 theta is equal to 1/2, and theta has to be somewhere in between 0 and 2 pi. So what you have to think of is if you take sine of 2 theta equals 1/2, you have to ask yourself, when would sine of theta be 1/2? Okay, so sine of theta would be 1/2. So sine of theta would equal 1/2 at theta equals, let's see here, that would be pi over 6, and also at 5 pi over 6. All right, that would be when sine of theta is that. But the problem is we do not have sine of theta. We have sine of 2 theta. So then we need to figure out when would 2 theta equal pi over 6, and we need to figure out when would 2 theta equal 5 pi over 6. Okay, so what we would do is we would solve for theta, and then, so basically I just need you guys to understand what I did here is I said that I know that pi 6 and 5 pi 6 would make the original sine function equal to 1/2. But I don't have the original sine function. I have 2 theta. So we're going to learn some identities that could help us with this problem later on maybe. But for now, what I do is I say, well, that means that whatever I plug into here has to eventually become pi 6 or 5 pi 6. So what I'm going to do is I'm going to solve each of these for pi halves. Or for 2 pi, I'm sorry. So then we cancel, 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 cancel. This would become, let me see, this would become pi over 12, and this would become theta equals 5 pi over 12. Okay. Now the thing is that is if, how do I say this? That is if we're dealing with 0 to 2 pi as one period, right? But now this is 2 theta, so let me put 2 theta in here. Let me do a little scratch work over here. Let me put 2 theta. Let me say 0 is less than or equal to 2 theta, because that's the actual angle we're dealing with. I'm going to divide by 2, divide by 2, divide by 2. So now I have 0 is less than or equal to theta is less than pi. So that means that every period of this function is a theta. Well, if we're going from a pi. If we're going from 0 to 2 pi, that's the angles we're allowed to use. That means that I have to add a pi to each one of these angles to get another possible angle, okay? So now I'm going to take theta equals pi over 12 plus a pi, and theta equals 5 pi over 12 plus a pi. So theta could also be, this would be what, 13 pi over 12, and theta could also be, what is that, 17 pi over 12? So as it turns out, this is the solution set for theta. Theta is equal to 5 pi over 6, right? Oops, I'm sorry, not 5 pi over 6. The first one we found, which was pi over 12. We now have 13 pi over 12. The original one was 5 pi over 12, and we now also have 17 pi over 12. So we had to adjust this because this is already done with one period from 0 to pi. So remember, a period means that it's going to repeat the values every period. So that means from 0 to pi, and then from pi to 2 pi, it's going to repeat itself twice. So what I did was I found the doubles. So there's actually 4 answers that would work for this, 4 angles from 0 to 2 pi that would work. And if you take any of them and plug them in here, you will in fact get 1/2. So one of these new angles we got was 13 pi over 12. So if you want to check it, I could just do a check right here, and I could say sine of 13 pi over 12 times 2 better equal 1/2. So this is going to be the sine, cancel, of 13 pi over 6. So if I look at my unit circle, 13 pi over 6, well, here is 6 pi over 6, here is 12 pi over 6, and here is 13 pi over 6. Well, we're right back to pi 6, right? So, and the sine of pi 6 is 1/2, so this actually works. So that's what I'm doing, is I'm checking all of these answers and making sure that they would work in the original, and they do. So that's just something you got to be careful of. Whenever there's something inside with the theta, you got to be careful of that. Okay, let's look at number 3. So let's work with a tangent function. So let's say we have, tangent of theta minus pi over 2 equals 1. And we know that we're dealing with from 0 to less than theta is less than 2 pi, okay? So we know that tangent normally has a period of pi, so we got to see maybe there's 2 answers in here, okay? So what I'm going to do is we know that when would tangent equal 1? Well, we know, oops, why did I write it like that? We know that tan of regular theta would equal 1 when theta equals pi force, and what is it, 5 pi force, right? That's when, if you plug either one of those angles into here, you would get 1, right? 45 degrees or what is that, 225 degrees. And we would get positive 1. So what I need to do is I need to find out when would theta minus pi over 2 equal pi force, and when would theta minus pi over 2 equal 5 pi force. So that's all I do, and I get theta equals, now that would be what, 2 pi force, so that'd be 3 pi over 4, and this would be theta equals, let's see here, add a pi halves, add, geez, my mind just froze right now. 2 pi force plus 5 pi force is 7 pi over 4. So then my solution set for theta is 3 pi force, comma 7 pi force. And these would be my values that if I plug them back into the problem, I could get them to work, okay? And again, you guys should check some of these when you have a chance, go through and plug them in and see if in fact this does work. You can even use your calculator for this. Now these next ones I want to do are slightly harder. Let's do solving in quadratic form. Okay, so I could give you 2 sine squared theta minus 3 sine squared theta. Oops, not sine squared, just 3 sine theta plus 1 equals 0. And again, we're going to go from 0 to 0, oops, 0 less than theta less than or equal to, oops, less than 2 pi. Just kind of in general so we don't have an infinite amount of answers. Okay, so what we do is we say, well, this is a sine squared, this is a sine, and this is a 1. So we can't really do it how we want, like we did for these problems up here. We can't really do the same type of work right there. So what we're going to do instead is we are going to try to factor this. Now, in your mind, pretend that this is just u squared and this is just u. So this would be 2u squared minus 3u plus 1 equals 0. So we could factor this as 2u and u, and this would be minus 1 and minus 1 equals 0. So then we would do 2u minus 1 equals 0 and u minus 1 equals 0. So then we would have u equals 1/2 and u equals 1. But the problem is we're not solving for u, we're solving for sine. So I'm going to go back in and plug what I said u was. So over here we might write u equals sine theta. So then u squared is equal to sine squared theta. Okay. So then this will become sine of theta equals 1/2 and sine of theta equals 1. Well, the sine of theta equals 1/2, we know pretty well. We've been drawing the unit circle quite a few times now. That will be pi 6 once again. So we know that theta equals pi over 6. We also know that sine is right here, also 1/2. So that would be 5 pi over 6. And now when is sine of theta 1? Well, that would be right here, right? Right at 90 degrees. So we say pi over 2. Now down here, it would be -1, so that doesn't count. So we're just going to use these 3 values. So we get theta equals pi 6, theta equals 5 pi 6, and theta equals pi halves. So this one comes from this guy, and then these two come from this. Okay? So again, it's not like you ever really forget the quadratic. Whenever you get something that might work in quadratic form, you give it a shot in this technique. Okay? And again, all I'm doing with my unit circle, you guys, is I'm taking this and I'm drawing my unit circle, and then I'm finding my angles that give me those values. So right here, I know pi 6 would have it, and then this is the matching sine value right here of 5 pi 6. And then I also know here at pi over 2 would give me sine of theta equals 1, okay? Because the sine coordinate is, or sine is associated with the y coordinate. So let me give you guys a couple of these to try. So that was number 4, I believe. So let's try number 5 now. So this one might be a little bit tougher. Let's see, 3 cosine of theta plus 3 equals 2 sine squared theta. And once again, 0 is less than or equal to theta less than 2 pi. Okay, so solve this one. Just solve. So pause the video. Give yourself a chance to try to see if you can figure it out without me telling you how to do it. And then when we unpause it, we'll do it together. Okay, so hopefully you guys made some headway. You might have run into trouble because this is a cosine and this is a sine. So they kind of don't mix, and it's a sine squared. So we kind of have trouble factoring if they're not even the same type of thing. So what we're going to do is we're going to try to use an identity. So you guys remember that sine squared theta plus cosine squared theta equals 1. So I could solve for sine squared and get 1 minus cosine squared theta. If I get 1 minus cosine squared theta, I could plug that in right there. So this would be 3 cosine theta plus 3, did I write this correct? Yeah, plus 3 equals 2 times 1 minus cosine squared theta. Now everything has cosines and cosine squareds. So let's do some cleanup. And this would be 2 minus 2 cosine squared theta. Let's get everything on one side. So this will be 2 cosine squared theta positive plus 3 cosine theta. And when I subtract 2, this would be plus 1 equals 0, I believe. Yes. So now we try to factor, and this will become 2 cosine theta. And you don't have to convert it to U if you can already see how to do it. Some people just prefer to use U substitution in these problems, but I don't really care. I can make it work with either one. And then when I distribute, it would get back to the same thing. So I know this is right. So I'm going to set 2 cosine theta plus 1 equals 0, and cosine theta plus 1 equals 0. This will become cosine theta equals negative 1/2. This will become cosine theta equals negative 1. So once again, what you guys should do is you should be drawing your unit circle real fast. It's just should become kind of like a bread and butter thing for you where you just do it instantly. And then you have to think in your unit circle, when is cosine of theta negative 1/2? When is the x coordinate negative? Well, that's going to be in quadrants 2 and quadrant 3. So cosine of theta equals negative 1/2. That's going to be at right here, 2 pi thirds. And it will also be right here at the other 60-degree angle in that quadrant. And that would be 4 pi thirds. Okay, now for cosine of theta equals negative 1. Well, right here, this angle, so from here to here, that angle would give you cosine of theta equals negative 1 comma 0. So we know that this is theta equals pi. And over here, we know that theta equals 2 pi over 3 comma 4 pi over 3. So in general, this is how I think in the homework, they may ask you to write it. 2 pi over 3 comma 4 pi over 3 comma pi. They just want you to write it as a set. If they don't ask you to do it that way, then you can just do theta equals this and theta equals that, so on and so on. Okay, but these are just common problems that you're going to run into from chapter 7.3. Okay, I think I have one more. This one's a little bit more difficult. I wish I had one. Yeah, maybe I'll have to make one up and see if it works. So let's do sine. So this will be what, 6? Let's do sine squared theta minus cosine squared theta equals 1 plus cosine theta from 0 less than theta less than 2 pi. Okay. So what I want to do first is we either have to make a decision. We're going to turn everything into cosines or we're going to turn everything into sines. Well, it looks like we need everything to be cosines because we have this cosine over here. So I'm going to do this as 1 minus cosine squared theta minus cosine squared theta equals 1 plus cosine theta. Okay. Now this will become negative 2 cosine squared theta plus 1 equals 1 plus cosine theta. I'm going to move everything to one side so we get 0 on one of the sides. So this will be 0 equals 2 cosine squared theta plus cosine theta. And then this would be plus, well, let me see, when I subtract this, that's gone and that's gone. So that's our answer right there. So that means that we don't really have the normal, double parentheses sets of factoring, but what we can do is we can factor out a cosine of theta, and that would leave me with 2 cosine theta plus 1. Now, the thing is that we say cosine theta equals 1, or I'm sorry, cosine theta equals 0, and 2 cosine of theta plus 1 equals 0. So then theta here would be what? When does cosine? That would be pi halves and 3 pi halves, right? My unit circle. That's going to be right here. My x value would be 0 right here. And then also right here, okay? Now we do this one over here, and we get cosine of theta equals negative 1/2. So then you ask yourself, when would theta equal, or what angles would give me negative 1/2? And once again, This would be cosine would be 1/2 would be negative. So we would have to be in which quadrant if we want our cosine to be negative? We have to be in quadrant 2 or quadrant 3. And we need it to be the version. So this one has these coordinates, 1/2 comma square root 3 over 2. So my cosine is 1/2 there. So then that means the negative version of it's right here, and that's 2 pi thirds. And then we need to find the positive version. I mean, the one in quadrant 3 right here, which would be 4 pi thirds. So we have 2 pi over 3 comma 4 pi over 3. So this time we have 4 answers. Theta equals pi over 2 comma 3 pi over 2 comma 2 pi over 3 comma 4 pi over 3. And that would be our 4 answers. Okay, so this is kind of how it works with when you're doing solving trigonometric equations. You also, if you ever run into, let me just see if I can make one up that'll do what I want. Let's say that we have, I think this is 7, right? Yeah, let's say that we make, let me see, sine squared theta plus let's say sine squared theta, let me do 2 sine squared theta plus sine theta equals, let's say 2. No, let's say 3. Yeah, let's say 3. Okay, so if I ask you to solve this, and obviously it's from 0 less than theta less than 2 pi. So let's say that I just ask you to solve. Okay, so what we would do is we would factor out sine theta, and we would have 2 sine theta plus 1 equals 3. And then we would set each of these equal to 3. Let me think about this real quick. No, I don't want to do that one. So something that you guys have to keep in mind is when you're working with these problems, if you ever run into this situation where you have the sine of theta equals 2, or you have the cosine of theta equals -3, these are not solvable. You cannot do these problems because there is no value for the sine of theta equals 2 and the cosine of theta equals -3. It just can never happen. So sometimes you have to throw out your answers. I actually don't see one that I have. I'll have to find another one from the homework or something like that. I don't feel like I have a good one in here. Let me see now. So that's what I was going to talk about, but I didn't want to make one up and then butcher it. So I'm going to try to figure one out in the homework and see where that happened. But in general, you always have to keep in mind the restrictions that are put on sine and cosine. Okay. In general, that's how you do everything. So, oh, I see what I could have done. Okay, maybe, you know what, I think I have it. So let's say that we do, I'm trying to make it up and it's not working. Let's say that we do 2 cosine squared theta you know what, I'm going to do 1/2. 1/2 cosine squared theta plus sine cosine theta equals 0. So what I'm going to do is I'm going to set this, factor this. So this will be cosine theta. Yeah, I think this will work better. 1/2 cosine theta plus 1 equals 0. There we go. I think I got it now. So this will be 1/2 cosine theta plus 1. So now I'm going to set cosine theta, and this is obviously cosine theta equals 0. And then we have 1/2 cosine theta plus 1 equals 0. So this one will be, when is cosine of theta? This is pi halves, comma 3 pi halves. We know that from the unit circle. However, this one would be 1/2 cosine theta equals -1, right? Because we subtract 1. Then we got to multiply by 2. So then this would cancel and cancel, and we'd be left with cosine of theta equals -2. So this is your answers, but this one you can never find. If you even tried to plug it in your calculator, it wouldn't work, because remember, cosine and sine are always between -1 and 1. The cosine of any angle will always come out to be between or -1 to 1 or in between, and the same with sine. So this can never happen. So we have to throw this out, and this is our only true answer. So the other factor actually didn't help. We couldn't do anything with it. That's what I was trying to show you, but I was actually about to make a silly mistake in the previous one, so I needed to come up with a better one. Okay. This one is a better one. Okay, so hopefully that helps you guys get started on 7.3. Let me know if you need any help, and see you in the next meeting or the next video.